Hello friends, good morning. So as in last video session we discussed about the phase lock loop, and we already understood how the PLL is going to work. And as we talked last time, that the next session will be going to focus on understanding how the FM demodulation is done by the phase lock loop. So today we will going to understand with the help of this video how the FM demodulation is done with the help of phase lock loop. Now, as the block diagram of Vco, we have as the block diagram of PLL, that what we already seen in last video, and we were already known about it. And because of the low cost and the superior performance of phase lock loop, especially when there is a consideration of low signal to noise ratio, the FM demodulation using PLL is most widely used today. So we saw how the PLL tracks the incoming signal angle and instantaneous frequency as well. Now if you observe the block diagram what we are considering here, the output A0 T of the loop filter, which is H of S, so that acts as an input to the Vco, and the free running frequency of the Vco is set at the carrier frequency, which is omega c. Now the instantaneous frequency of the Vco, we have already seen in last video how it should be represented. So the same what we are representing here. So this is the instantaneous frequency of the Vco, which is omega, or omega Vco is equal to omega c plus c E0 of t, and all this constant and that we know basically. Now if the Vco output what we are considering is b cos of omega ct plus theta naught of t, then the instantaneous frequency will become omega c plus theta naught of t dot. So I'll just write down here. So the instantaneous frequency will be omega c plus theta naught of t, and the differentiate part out of theta naught t, and therefore the theta naught t that can be given as theta naught of t equal to c E0 of t, where the C and B, which we are considering here, so they are the constants of the PLL. Now let consider the incoming signal which is coming to the PLL. So we are considering as A sine omega ct plus theta I of t. So this is we are considering as an input signal or incoming signal to the PLL. Now if the incoming signal is happen to be in this particular form, A sine omega naught t plus phi of t, so it can still be expressed in this particular format, which is A sine omega ct plus theta I of t. So where this particular theta I of t, that is equal to the omega naught minus omega c t plus phi of t. Therefore the analysis that follows is general and not restricted to the equal frequencies of the incoming signal and the free running frequency of VCO signal. So in block diagram, if we just check, right, so there is a multiplier which basically going to deal with the two signal, which is the incoming signal and to the PLL and the output of the VCO. So that's basically the multiplier, right? Now the multiplier output which we may have, right, so that may be consider here. So this may become my output, okay. So this will be my output of the multiplier what we have considered. So here is this particular my output. So that I will be observed as an AB sine omega ct plus theta I into cos of omega ct plus theta naught. So in multiplication, okay, so if we apply the trigonometric relations, okay, so then we will observe that this will become as an AB by 2 sine theta I minus theta naught plus sine of twice omega ct plus theta I plus theta naught. Now the sum frequency term is suppressed here by the loop filter that what we are considering. So hence the effective input to the loop filter will be will be 1 by 2 AB sine of theta I of t minus theta naught t. Now in this case, let's say if we consider h of t as my unit impulse response for the loop filter h of s. So the output what I may have here, that is E naught of t, okay, to the impulse response h of t, and to it my multiplier output, which is nothing but the input to the loop filter h of s, that is 1 by 2 or 1 by 2 AB sine theta I of t minus theta naught of t. So that will be going to be observed in this particular format, so which is the conventional way of having the convolution. So that's what we generally observe. So that will be my output. Now if I'll just go a little bit back, and if I'll just observe this particular equation, which is this one, let's say I'll just mark number to this equation, let's say as equation number 3. And I'll just observe the last equation, that what we have just check here, which is this one, 1/2 AB, this one. So let's say if I consider this as a equation number 4. So let's say this is my equation number 4. So if we just check here a little bit, so we may just substitute the equation number 3 into this particular equation number 4 what we are considering, and probably we may talk here about this particular element, which is my theta dot of t. So in the regard putting the value, so I may get this particular equation where the k having the value 1/2 CB and my theta E of t is the phase error. So this particular phase error is generally defined in this particular format, or in this particular way: theta E of t equal to theta I of t minus theta naught of t. Now all these equations, so including the equation number 3 what we have seen earlier, and all these equations what we are observing, which are the representing basically the E naught of t and theta naught of t dot and theta E of t as well. So all these equation, so this equation basically suggests a model which probably look like the figure which we are considering over here in this particular video. So this particular figure, if you trying to understand, so this particular figure is basically going to observe with the help of all these equations what we are considering. So maybe you are observing the theta naught which is here, so that is the C E of t. So this is my output basically, which is the coming from loop filter, and which is going to the voltage control oscillator, where there is an integral part, and the output which is coming as theta of t. So this basically give us, this equation basically will give us this particular format of as an equivalent circuit for the phase lock loop what we have considered initially. So if when we consider the incoming FM carrier, so maybe in this particular form which we are already considering as a sin omega ct plus theta I of t. So here, observing the value of theta I of t, so on the basis of initial equation, so I may write down as k of integral minus infinity to t m of alpha d of alpha. Let's say I am defining currently in the variable alpha. So therefore, if again I am going to talk about the theta naught, so theta naught, which is basically the my output, and theta e, if I just observe here, so that was my input actually. So even though the theta naught I am observing here, which is the output of my VCO, so that is my theta naught. So theta naught, okay, so what I am observing here, so that is here k of, again, the integral minus infinity to t m of alpha d alpha, and there will be the little bit error which may consider as theta e, so that error which is over here, right? So just considering the initial equation of theta e of t, so which is equal to the theta I. We have seen this equation. I'll just quickly take you a little bit back so that you can easily understand or easily correlate. So if I just check this equation, so here we will understand how that theta naught of t is going to be observed. So my theta naught of t will be k of minus integral t m of alpha d alpha minus theta of e, which is my error. Now let's say if we assume that this error is going to be very small, or maybe considering as a small error, theta e what I am considering. So what the end I am observing, right? So this is the equation, this output here, which basically the theta naught dot which is equal to C E naught of t. So here what we are observing this here, so this E naught t, right? So here this is the differential output, okay, theta naught. So if I just want to express this output E naught of t in terms of theta naught dot, so I'll get the expression in this particular format. So the value of theta naught dot t, that basically what I'm observing here. So this is the in the alpha, okay. So if you again going to differentiate, so the integral sign will remove and we'll observe this particular into the m of t format. So if we just trying to understand here, so the output which I am observing with the help of this particular model of PLL, so I am observing the output again in the form of m of t. So m of t, that is the basically my modulating signal, right? So this is the particular way that how the PLL that acts as an FM demodulator. Now if the incoming signal is a PM wave, then the theta naught of t what can be considered, that is going to be multiply with the factor kp instead of kf to directly m of t. So there will not be the integral sign, and so when going to observe the e naught of t, so directly it is going to have the format of the particular constant what we may consider as a kp, and here directly here instead of m of t I'll get m dot of t while considering for the PM. So that is what is the basic difference while again in demodulation process of PM and FM. So in this case we just need to integrate the E of t to obtain the desired signal. Basically this is the approach, or this is the mechanism how the particular phase lock loop is going to demodulate the FM signal. Now FM signal, which is the modulated form, so that has been converted into the m of t or the message signal form. So there are the two analysis basically. So there are two further analysis basically, which again going to help us to understand deep how the particular error that what we are considering or what we are observing as theta e, how that can be reduced or how that can be neglected or how it can be removed. So there are the two ways of analysis. One is called the small error analysis approach, and there is one more approach which is generally used, that is the first order loop analysis. So I hope you understood how the PLL is going to use for FM demodulation, or how it is actually going to demodulate m of t from the FM signal, which we generally observe in the format of a sine omega ct plus theta I of t. If you have any queries, any questions, so you can post to our Google Classroom, so we will have the discussion over there, or we will going to solve all the queries through our question answer session. Thank you very much and be safe.